Okay, we are going to take polynomials and we are going to factor them completely in this section. But what you need to understand is what each of these are. So if I gave you a problem like this, I started, x, I want to do x squared. If I gave you a problem like this, okay, and I asked you to factor it completely, is this factored completely?
No.
No. What could I do to this problem?
You can make
X minus 3.
I could make this x minus 2 times x plus 2, right?
Yeah.
So what are, what
Three
are
zeros.
these numbers right here inside? Well, the opposites of them are the
Zero.
zeros. So do you all agree that this polynomial has 3 zeros, and they are 3, 2, and -1, right?
Yeah.
Hi. Wait, did you say -1?
I'm sorry, -2. Did I say -1? 3, 2, and -2. These are the zeros.
Hello.
Now, what kind of zeros are these? These are called rational zeros. These are all rational zeros. Why are they called rational zeros? Because I can make them a ratio of 2 integers. What's nice about rational zeros is when I graph them, I know exactly where they're at. Where is 3, 1, 2? Here's 3, here's 2, and here's -2. There's no question about it. Can you pass this to Rico?
Have a pass.
That's the
Okay,
pass.
now, so the multiplicity of each of these zeros is odd. So the graph is gonna go through each of these. So the graph is gonna look something like this, right? Okay, it's gonna cross through each of these zeros. Well, what if I gave you this problem? So what did we call these zeros? These are called rational. What if I gave you this problem, x minus 3, and then I did x squared minus 5?
Oh.
Ooh.
You're not gonna get
Okay, now let's look at these answers. I get 3, but what do I do for this right here? How do I finish this one off? I'm going to set this equal to 0. I'm going to add 5, right? Square root both sides, and x is plus or minus the square root of 5. Well, does anyone know what the square root of 5 is?
No, hold on.
Well, let's do it. The square root of 5 is 2.236067977. Where is that number on the x-axis? Where is 2.23606? And guess what?
Right here.
This is chopped off. There's more numbers. Can anyone tell me what kind of number that is? Is it a rational number? No, it is not. It's an irrational number. This number, it's a crazy number. It goes on and on and on. It doesn't repeat. It doesn't end. It's a rational zero. So this is an exact answer. This is approximately, we do a squiggly line, it's approximately plus or minus 2.2. Approximately. So when I go to graph this one, I'm going to put a dot at 2, or a dot at 3, I'm sorry, and a dot at about 2.2 and negative 2.2 right there. So this dot is about negative square root of 5, and this dot is about positive square root of 5, and this is the number 3. So these are called real numbers, but these two are irrational and this is rational. So these special kinds of zeros are irrational, but they're still real. This is real and this is real. They're real. They're real numbers. One is called rational and these are two irrational. Now what if I give you this problem? X plus 1, and then I do x squared plus negative 3. I should just write minus.
I don't
No,
know why.
I'm sorry,
Just
plus.
minus, oh,
just plus 3, no negative, sorry. So, what do I
square
do
root
here?
3i.
This is negative 1, everyone okay with that?
Yeah.
Now this one, x plus 3, you're gonna set this equal to 0, and what do I do?
Square. Well, now you have an I under, or negative under the square.
Plus or minus the square root of 3i. Well, what kind of answer is this?
Imaginary.
It's imaginary. So this is a rational, real number. This is imaginary.
You're right.
So when they ask you to find, if I gave you this problem and said, give me all the real zeros, what would you say? Just negative 1. If I said, give me all the zeros, you would say negative 1 and plus or minus the square root of 3i. So you need to know the difference between the directions. It's very important for you to know, be able to read it and answer their question. So if it asks you in these problems, if it said if this one said find all rational zeros, or if it said find all real zeros, you'd say 3, 2, and negative 2. For this one, if it said find the rational zeros, what would you say for an answer? Find all the rational zeros, what would you say? Just 3. What if it said find all the real zeros? You'd say 3 and plus or minus square root of 5. What if it said, for this one, find all the rational zeros? You'd say negative 1. What if it said find all the real zeros? You'd say negative 1. What if it said find all the zeros? You'd say negative 1 and plus or minus root 3i. So, real means rational and irrational. So what is a rational number? It's a number like 0, 1, 2, 3, negative 1, negative 2, negative 3, and numbers like a half, a third, a fourth, 0.75, 0.50. So any number that you can write as a ratio of 2 integers. These are our favorite ones. We can find these ones on a graph, easy. Those are rational numbers. An irrational number is a non-repeating, non-terminating decimal. Non-repeating, non-terminating number, decimal. For example, the square root of 2, 1 minus the square root of 3. These two sets of numbers make up the set of real numbers. So when they ask you for real, they want both of these. When it says find all means real and imaginary. All means real and imaginary. Does everyone understand the difference? Yes.
Can you go back to the definition of
Irrational. An irrational number is a non-repeating, non-terminating decimal.
Like pi.
Pi.
No, it goes on forever.
It doesn't repeat, it doesn't end, it goes on and on. But like 0.33333333, that repeats, that's 1/3. You can make that 1/3. Okay? So now, knowing you have to read the directions. Because if they ask you in this problem, if it says find all the rational zeros and you write 3 plus or minus root 5, it's wrong. If it says find all the real numbers and you put these 3 and plus or minus, then it's correct. Same with this problem. If it says find all the real zeros and you include this one, it's incorrect. It is incorrect if it's asking for only real and you include ones with a negative under the radical. These are not real. But if it says find all is real, and real is irrational, and rational, and imaginary. It's very important that you understand the directions, okay? So that's, I spent a lot of time on that, and I hope that I don't have to mark any wrong if it says something and you put any, a lot of times people don't understand the directions, so they write everything down. It's kind of like in an English class when the teacher asks you to write a paper and you just start rambling on and on because you're not really sure what they're asking, so you figure, you know what, I'll just write about anything. Sometimes teachers, tell me if I'm wrong, if you're an English teacher and you start rambling on, they will mark points off. That would be like an example of this in a math class. If I ask you a question and you don't answer the specific question, it's going to be marked wrong. It's right if I ask something else, but it's wrong in this case. So I need you to understand, I don't want anybody arguing with me. When you get a question like this, I'm spelling this out for you because it happens every single year. Okay? And I will refer to this moment. All right, now, I'm going to go through, we're going to start talking about how to find all of the zeros of a polynomial. Now, if the problem was x squared, what is x squared? Blah, 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 blah. So if I gave you something like this, and I asked you to find the zeros. Well, this is easy. We can try to factor it. Number two, if it didn't have this term right here, the middle term, we could take the square root of both sides. Remember that? If it's a squared problem and doesn't have the middle term, we can set this equal to 0 and factor it by taking the square root of both sides. Number three, if the middle term is even, do you remember what we did in that one? We completed the square. I'm abbreviating, complete the square. Number four, if the a value is a number like 5 and or the middle term is an odd number, we can use the quadratic formula. What is that? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Number 5, and I try to avoid this one, we can use technology, and we'll spend a lot of time in pre-calc doing the technology using the calculator. Okay, we're using more of these methods because we want you to learn the methods before you take a calculator out and have that do it for you. But we will do this. Technology is important to know. Now, what if it's not an x squared problem? There's got to be ways to factor these to find the zeros. Well, this is what I'm going to teach you today. It's called the rational zero test. This is what we're concentrating on today. That's going to help you. And the rational zero test is used in conjunction with these methods. Because what you're going to do is take a problem like x cubed. You're going to find the first zero, like we did yesterday using synthetic division. You're going to break it down to x squared, and then you're going to apply these methods. So, well, how do you do this? Let's start with problem number 1. We talk about P and Q. P is going to be the last number, the constant. I need to know what numbers go into 3. In other words, what are the factors of 3?
Well, it's just a prime.
Plus, so 1, it's prime, so 1 and 3 go into 3. Does everybody understand that? You will include pluses and minuses. So, what numbers break up will make 3? 1 times 3. Now Q, what is Q? Q is your leading coefficient. Q is 1. What are the factors of 1? Plus or minus 1. So now, we've got this P over Q. P over Q means you're gonna take all the possible factors of P, which are 1 and 3, and you're gonna divide it by the factors of Q, which are 1. With these, you are gonna come up with combinations of plus or minus 1 over plus or minus 1, plus or minus 3 over plus or minus 1. So can you, by switching the signs, can you list all of the numbers? You have 1,
It's time consuming.
it is. You have 1, you have -1, you have 3, and you have -3. So if we listed them in order from least to greatest, -3, -1, 1, and 1. You'll get quick at it. Whoops. 1 and 3, sorry.
Wait, how did you do that?
You take, see you have 1, you're gonna do 1 over 1, -1 over 1, 3 over 1, and -3 over 1.
Is it always gonna be like that,
Mhm.
or it's written,
Yeah.
where it's written the way it is, and those are the answers?
Yeah, these are the possibles, these are your possible zeros. These are your possible zeros. Now, you don't have to list them out like that, I'm just listing them for you. So, you're gonna come up with combinations of all the factors of P over the factors of Q. How many can you come up with? P over Q, you can get a 1 and a -1, a 3 and a -3 with these numbers. So what you're gonna do now, one at a time, you're gonna try to find, these are like hints. These are possible factors. You're trying to break this up into this right here. So I'm looking to find one of the factors that work. Let's try, I always start in the middle with 1. And I work this way, and then I work that way. What you're trying to do is use synthetic division. I'm gonna use 1. You're gonna use synthetic division. How do you do synthetic division? You put the coefficients in order from least to greatest, and if you have any holes, you put up a 0. Now, what your job is to find a 0 remainder. That's what you want. Don't force it. It's gonna happen or it's not. If it doesn't happen on the first try, you try another number. Now, I'm gonna try the number 1, right in the middle, and there's a reason why I'm gonna tell you in a minute. If you bring down the 1 and you multiply, and you add, and you multiply, we did this yesterday, right?
Yep.
If you test a positive number and you end up with all positive numbers here, we say that that number was too big. Try something smaller. We call that an upper bound. So if a number you test is positive, and all of these numbers are positive at the bottom, that number was too big. Try something smaller.
So in other words, what one don't you have to use?
So what one don't you use?
3.
Don't try 3. If 1 was too big, 3's bigger. Don't try it. Now there's a lower bound test.
Just the desk.
If you try a negative number and you end up with positive, negative alternating, that's a lower bound. That's too small. Try something bigger. Because sometimes your list of possible zeros get crazy. We're starting off small. Some of these get crazy. So now let's go to -1. Let's see if -1 works. You get 1, 5, 7, and 3. Bring down the 1, multiply, add, multiply, add. Oh, look what happened. We got our first 0, which is big, because now we can break this down 1 degree smaller than what we started with. So if this works, how would you write this in factored form? X
Squared.
X
X.
plus 1. Remember that? So what do you have here? These are the coefficients 1 degree less than x cubed. So what's our answer here? 1x squared plus 4x plus 3. So what we have so far, we have x plus 1, and then we have from this, we have x squared plus 4x plus 3. Now, can you tell me how to break this? This is where you're gonna kick into
X plus 3 and X plus 1.
quadratic mode. How do you factor something like this? Try to factor it. Can you factor that?
X plus 3 and X plus 1.
And you sure can. X plus 3 times x plus 1. And bring down x plus 1. Now, is there a way to write this better?
X plus 1 squared.
Mhm.
divided by X plus 3.
Now, why would you want to write x plus 1 squared?
It
What's
makes
the
it- It
reason?
makes it look less cluttered. It's more
Because the
concise.
multiplicity of this 0 is even. So I know that at -1, the two zeros are -1 and -3.
And it's gonna
What do
bounce.
I know what's going to happen at -1?
It's gonna bounce.
It's going to touch and bounce at that 0. Okay? Questions? Anybody? All right, let's
What's your
try.
answer?
Huh?
What's your answer?
Okay, good question. Let's read the directions. Use the rational root theorem test to find all, the word all. Well, actually, these are the possible roots. And then they want you to use to find any real, we want the real roots. And guess what? They're all real. These are all real. These are your roots. These are the zeros. So it's the answer is -1 and -3. Those are your zeros, -1 and -3. That's the answer. So let's try another one. Go to the back.
That's a lot of work.
Huh? There is. Especially, there are, and then and when you're absent, it makes it worse, right? Okay, so what's the p-value here? P is 2, so give me all the numbers that go into 2, 1 and 2. That's your numerator, plus or minus 1, plus or minus 2. Now Q, oh, we have a few. What numbers go into 9? 1,
3.
3, and 9. So in the denominator, we have 1, we have 3, and we have 9. Can you list for me all of the combinations? We have 1 over 1. So we have 1 and we have -1. We have 2 and -2. See, I'm going to take this and put it over here. Now we have 1/3 and -1/3. And then we have 1/9 and -1/9.
Awesome.
Now, what I would do is I would put my numbers in order from least to greatest. Rico,
Where did 1, 3, and 9 come from?
what numbers are factors of 9? 9 is your Q value.
Oh,
What numbers go into 9? 1 goes into 9, 3 goes into 9, and 9 goes into 9. So it's P over Q. So if we started from left to, what's the smallest number here is -1/9. If I go in order,
Would
-1/9.
-1 be the least?
Oh, yes,
That's
I'm
not
sorry,
full.
actually -2 would be the
Oh,
least.
yeah.
-2, you're right, -1, then -1/3, right?
Yeah.
Sorry, and -1/9. Then we have 1, actually no, what would be
1/3.
next? 1/9,
Oh,
then 1/3, right?
probably.
And then 1, and then 2. Now, I would suggest, before you do these fractions, do 1 and 2. I would stay away from these fractions, because it's gonna be very messy. So let's do 1, let's do synthetic division. Hopefully, we get our first answer. If not, we have to use the fractions. We're gonna do 9, -30, 23, and 2. Do we have any holes? No, we're good. So bring down the 9. What is 1 times 9? 9. So you're gonna add, what do you get? -21. Multiply, what do you get? What do you get?
-20.
I get 2.
So you add.
Oh,
Or use
you
it.
said
Oh,
multiply.
multiply and then add, 2. And then what's 1 times 2? 2. Did we get a 0? I wish.
But
You can
what you
use
do
negative
know
one.
is that because those are the same term, if you put the opposite sign,
Yeah, if you do
those
negative
cancel.
one.
Okay, so what are you saying? You wanna try negative 1?
Negative 1.
Let's try negative 1. Let's use your theory. Let's try it. 9, negative 30, 23, and 2. Let's try it. Bring down the 9. What do you do with these two? What do you get?
39.
Add, multiply?
There you go.
Is it working?
No.
62.
No. Uh-oh.
I think it works.
Let's try,
It'll be 60.
Yeah, it'd be negative 60.
oh, negative
anyway.
60, yes, sorry.
Did you always add
You, with synthetic division, and this is what you missed yesterday, you bring down the first term, you multiply, you put that there, and you add. Multiply, add.
them? So where's
Multiply.
negative 30? Like, that's what I'm
Negative 1 times negative 39 is
This
positive
times this
39.
is negative 9, and then you add these.
looking. And then you times it by negative 1?
This times
Okay,
this is
that's
39, add.
Okay.
Multiply and add. Okay, anyone wanna give, have another suggestion? Wanna try, let's try 2. Let's try the number 2. So if we put a 2 out here,
But didn't you know it's already gonna be too big? Because
is it
That we
too
did
big?
last time.
No, because we have a negative here. Now, if, according to the upper and lower bound, actually, look at this. This is a lower bound. Negative 1 is a lower bound.
So
When you try a negative number and you have opposite signs, this is too small. So what you want to do, if negative 1, let's go to our list, negative 1 is too small, so guess what? We don't need to try negative 2, because that won't work, that's smaller.
right.
And 1 didn't work, so we may have one of these fractions here, okay? Hopefully I didn't make a typo. Let's try 2. We're gonna try 2 right now. 2, negative 30, 23, and 2. Not, bring down the 9. 9 times 2 is 18. What do you get? Negative 12, right? Multiply, you get negative 24. Oh, I'm happy. And it works. Thank God, we got our first 0. So how will you break this up here? We've got x minus 2. That corresponds with x minus 2 corresponds with x minus 2. Now what's left here? These are the coefficients. So it's going to be 9x what? Squared minus 12x minus 1. Now guess what? We are now at the x squared mark. So bless you. Guess what we get to do now? We can try to factor it. We can't take the square root of both sides because it's got a middle term. We could try to complete the square, and I wouldn't want to complete the square on this one. Or you use the quadratic formula. So,
Where did you getting that equation?
what?
9x squared minus 12x.
This is what you missed yesterday.
Okay, so
these-
just keep going then.
These are the coefficients of the answer 1 degree less. This is what you missed yesterday.
Yeah, I'll just look on YouTube.
So it's 9x squared minus 12x minus 1. The rest of you guys know, she's a little lost because she wasn't here yesterday, but do you guys know what I'm talking about?
Yeah.
Where this came from? Okay. Now, this might be factorable. Does anyone know if this factors? 3x. I'm looking at these two and saying, hey, these are perfect. Let me see. Plus, let's try. No. Does that work? No, because that's going to give you, that's the difference of 2 perfect squares. Does anyone know? How about 9? Is 9 and 1 going to work? Or we may have to use the quadratic formula. No, this isn't going to work. We're going to have to use the quadratic formula. So, what is the quadratic formula? So if it's not factorable, guess what? More than likely, it's an irrational. These are 2 irrational zeros. So you get negative b plus or minus the square root of b squared minus 4ac all over 2a. How many times have we used this formula? A lot.
12.
So for those of you that are still struggling with this,
142.
you gotta get it down. 144 minus 9 times A with, 4 times 9, 4 times 9 times negative 1. So over 2 times 9, which is 18. So help me out here, 12 plus or minus, we have 144 plus 36, which is 180. And guess what? I know that 180 is not a perfect square. So we are gonna have,
But you
it's a
can
real,
divide it.
it's real, because there's no negative here. So how can you break up 180? Isn't that 10 times 18?
Well, could you divide it, like, find a common thing that they could all divide by first to get it a smaller number?
No, you have to simplify that. So look what I did, I took 180 and I said 10 times 18 is 180, and 10 is 2 times 5, and 18 is 2 times 9, and 9 is 3 times 3. So what could I take out? I could take a 2 out and I could take a 3 out. So 180 simplifies to be 6 root 5 over 18. Now, can you tell me what number goes into 6? What's the biggest
6.
number that 6, 12, and 18 is 6. So 6 goes into 6 once, 6 goes into 12 2 times, and 6 goes into 18 3 times. So your answer is 3 plus or minus the square root of 5, I'm sorry, 2.
Yeah, I'm like, wait.
2. I'm looking at this. 2 plus or minus the square root of 5 over 3. So guess what these two answers are? These are irrational, but they still are real. These are real zeros. Now, obviously, I didn't give you a lot of room to write that, but write what you need to. Your zeros are 2 and 2 plus or minus the square root of 5 over 3. These are your 3 real zeros.
That's your answer.
Yeah, these are your this is your answer. There's 3 zeros. Now, I'm gonna have you figure something out on your own right now. This is a discovery moment. If I gave you this problem, or if I gave you this problem, or if I gave you this problem, let's do these really quick. This 0 is what? 2. How do I find these two? Remember I said once you get to x squared. Yeah, let's square root both sides. So off to the side, you set this equal to 0, add 5, square root both sides, and what do you get?
2.2.
What do you get? Plus
Plus
or
or
minus
2.
square root of 5. So there's 3 real zeros, 2 and plus or minus the square root of 5. What kind of answer is this? Classify this. Is it rational or irrational?
Irrational.
It's irrational. Okay, what about this one? Your answer would be -1. Does anyone know off the top of their head what this one's gonna be?
X plus or minus.
Square root of 5i.
5i, good.
I didn't know if you wanted decimals.
So this, no decimals, I want exact. So what did you get here? Plus or minus root 5i. This is real, what are these? Imaginary. How about this one? -6, what's this one gonna be? Plus or minus square root of 7. I can go on and on. This one, what's this one gonna be? Plus or minus root 3. Does anyone see a pattern with
You're
these?
picking, like,
with
numbers that
these-
you can't square root, you pick like prime number.
Okay, yeah, I'm picking prime numbers, but what kind of, classify these kinds of numbers right here, what are they?
Irrational or imaginary?
These are irrational or imaginary. What do you notice about all the irrational and the imaginary answers? How are they showing up?
You're up.
Not the fact that they're odd,
They're in square root,
they're what?
under the square.
Plus or minus.
Plus or
They're plus or minus. So anytime, and you can try a zillion cases, anytime you have an irrational or an imaginary, they come in pairs. Always. They're always in pairs. So if I give you this 0, what kind of 0 is this? Is this rational? No, it's
Irrational.
irrational. So if I give you an irrational 0, or if I give you this one, what do you know?
It's imaginary.
You also know that this answer will also occur, and this answer will also occur. They come in pairs. So if I give you one of the irrational and irrational, you know that the opposite sign will also occur. So check out, this is a very easy section. So, if I give you a quartic polynomial, quartic means 4th degree. That means there's 4 answers. And if I only tell you root 2 is an answer and 1 plus I is an answer, do you know the other 2 answers? Remember, it's quartic, so there has to be 4 answers. Tell me what other answer will occur.
Minus root 2.
Minus root 2, because they come in pairs. And what would this one be? 1 minus, it's plus or minus the square root. This is the square root. The I is the square root.
Okay.
So you'll have 1 minus, they come in, we call it conjugate pairs. This is called a complex number. A real and imaginary is a complex number. Okay, let's look at this one. I just want you to tell me, if 3i is a 0, minus 3i will also be a 0, and if the square root of 6 is a 0, what else will be there?
Negative.
6.
Mm-hmm. If 4 is a 0, will negative 4 be a 0?
No.
No, that's not irrational. So don't start giving me plus and minus 4. But if 5i is a 0, negative 5i is a 0. Now, what they want you to do, and I'm giving you a cubic function, and if I tell you 4 is a 0, 5i is a 0, and negative 5i is a 0, how will you write this in factored form? X, what do I write here? Minus 4, good job. Then what? X minus 5i, and it's, remember, it's the opposites of these, and x plus 5i. That's how you'll write it in factored form. Does everyone understand this? Now, we have to take it one step further,
Of course we do.
and we have to FOIL it out.
You're
So
gonna get a
what you're gonna
-1.
You're gonna get what?
You're gonna get the I squared, which is -1.
Yes, if you took these two right here and you factored it out, you're gonna get x squared. Now, the next two will cancel out, you're gonna get negative 5i squared.
25.
I'm sorry, 25i squared, yes, thank you. 5 times 5 is 25 and I squared. And what did you say I squared is equal to?
-1.
-1, so what
it's
is
a
this?
positive 25.
This is gonna be x squared plus 25. So taking these two and foiling them, you get x squared plus 25. Now, they want you to take x minus 4 and distribute that. So it's gonna be x cubed, and then plus 25x, and then minus 4x squared, and then minus 100. Sorry, I'm out of room. What's wrong with me? X cubed, now in order, minus 4x squared plus 20, do you know what I'm doing? I'm organizing it in standard form. That's your polynomial. Okay, so how do you do these problems? We're going to do one from each section. I want to do number 1. The back page is your homework. Let's do number 1.
There's like 2 pages.
Yeah, but it's not hard. You've got 6 of these. All right, I want you to find all of the roots, real and imaginary. So what are you going to do? What are the possible zeros? It's P over Q. So you have P is 1 and Q is 1 and 2. So where should we start? All we want to do is find the first one, then the rest we can factor. What number do you want to first try? I would try 1. Let's try 1. Okay, so we've got a 2, 5, 4, and 1. Now I can tell you right now, because I'm using a positive number and I don't see any negatives, that's going to be an upper bound. You know why? Because all of these are going to be positive. When I multiply and add, I'm going to get positives, and so 1 was too big.
Try negative.
Let's try -1. So you get 2, 5, 4, and 1. Bring down the 2. Multiply, add, multiply, add, and bingo, we got it. So -1 is one of your answers, but I like to write it in factored form. So it's x plus 1. You take the opposite of this. Now what's this going to be right here? 2x squared plus 3x and plus 1. Does everyone understand it? Sam, these are the coefficients 1 degree less. That's what you get out of this right here. So it's 2x squared. Why squared? Because I started with cubed. So you go 1 degree less. So and plus,
numbers.
these are the coefficients, 2, 3, 1. And this is this factor right here. Now what you're going to try to do is try to factor this. I think it's factorable. Anyone know how to factor this?
Just 2x plus 1 and then x plus 1.
Okay, so, and it works. So what do we have? Can I just put a squared right here?
No,
Why not?
because you have a
I had it
coefficient.
right here.
You don't have to.
I have 2 of them.
Oh, no, I was thinking like, you put
See,
it,
I'll
and you were
write it-
trying to include the 2x one, I was like, no.
See this right here? This is x plus 1, right?
Yeah,
This is this. These two give us this product right there. These are the products of that. And that was the -1 that we found. So can I shorten this answer?
yes.
What does it shorten to be? Okay, so now, can you tell me, I want all the roots. What are they? -1/2 and -1. That's it. Okay, now, so you're gonna do that for 2, you got 5 more. Now go to the back side. Okay, 7 through 12, all they want you to do is they give you 2 zeros. Can you name 2 more?
Yeah.
What do you notice about all of these zeros on these 6?
They have to kind of
They're
lie.
all either imaginary or irrational. So what comes with it?
Plus or
Plus or minus.
Yeah, so what would this pair be? 2 minus 3i? And what would this one be? -√7. You know what, let's kick these out right now. This will take a minute. Number 8, what would this one be?
Plus.
3 what?
Plus.
Plus √2. And what would this one be? 1 minus √3. What you do is change the sign in front of the square root or the imaginary number. Okay? Don't make it -3. This is what changes. These are plus and minus right inside. Does everyone understand that? Okay, how about number 9? If -4i is a 0, isn't 4i 1? If 6 minus I is a 0, isn't 6 plus I a 0? Okay, number 10. If 5 minus √6 is a 0, you tell me, I want to hear you.
5
5 plus √6 is? And if -2 plus √10 is? -2 minus √10 is. Number 11. Give them to me.
Negative.
Minus root
Five.
five.
And just √13. Good. Next.
1 plus
One
root
would-
10.
And,
2 minus root 10.
good job. Okay, now, what do you do on 13, 14, 15, and 16? They want the polynomial. So, what you're gonna do, how do you represent -5 in a factor?
Plus 5.
X plus 5. Do we write x minus 5 also? No, because that's just a rational zero. They don't come in pairs necessarily. Sometimes they do. So if 3i is a 0, what are you going to write?
X minus 3.
Well, guess what? You can't have 3i without having
Positive 3.
the opposite of it.
So I'm sure both.
So now, I want you to take the two imaginary zeros. I want you to FOIL this out. Some of you can do it in your head. It's going to be x squared what?
Plus, after you do the I squared. it's
You're going to get
plus
minus 9i squared. But what's I squared? -1, so this is going to be x squared plus 9. If you can do that in your head, go for it. Now your job is to bring down x plus 5, and they want you to write the polynomial function in standard form. So this answer is going to be x cubed, and then you're going to have 9x, and then 5x squared. I'm going to put this in order. Can you guys do that?
That's what I'm doing.
So, because I'm running out of room. So you're going to have first 5x squared, then 9x, and then 45. So guess what? You went from the answers to the polynomial. And now, look what this says. Write the polynomial function. They want you to put p of x in here in front. Okay? That is your answer. So, what are you going to do for homework now?
Coffee shakers.
You're going to finish. You've got 5 of these to factor, and really only 3 of these to do. And you're going to finish, try 17. It's a story problem. Brett, can you stop? Thank you.